The imaginary number I is equal to the square root of -1. That is the definition of I. And we said the other day when we started talking about this number for the first time, if it's part of our math system, it has to go with all the rest of the numbers. It has to have the same properties as all the rest of the numbers. So would it be possible to square both sides of this equation? Could I square both sides? Does that break any rules? And so then what is I squared going to be equal to? What's that equal to? The square and the square root would cancel each other out because they're opposites of each other. And so this would be equal to -1. Then could I multiply both sides of this equation by I? Would that be okay? And then what would this be equal to? It's already I squared. If you multiply it by another I, wouldn't that be I to the third power? And then if I multiply those two together, I would get -I. And so that's what they did to come up with this chart that's on the top of your note paper. You see that on the top of your note paper, that chart that's up there? I want you to circle this one right here. This is the most important one on the chart. I squared is equal to -1. Right there on your chart, circle I squared is equal to -1. Because you never, never, never leave I squared in a problem. Because what is I squared equal to? -1. So you change it to -1. Okay, would you please go to the back page of your notes and solve out these two problems right here. Once again on the back page of your notes. What's the difference between this problem and problem B? It has, instead of an X, problem B has an I. Other than that, it's the same problem. But we are never, never, never going to leave I squared in a problem. What does our chart tell us that I squared is equal to? So instead of having an I squared, the I squared is equal to -1. Well, what's -1 times 36? -36. You never, never, never leave an I squared in a problem. So this would be -35 plus 21I. So what is part C going to be equal to? When you have parentheses 4I squared. Well, what's 4 squared? And then that would be I squared. But I'm never, ever going to leave I squared in a problem. I squared is equal to what number? So I squared will always be replaced with -1. And then the final answer would be, that would be equal to -16. In problem D, you have to distribute, and you have to be careful about the signs. So when I multiply that by 1, I get -7I. When I multiply that together, I get positive 7I squared. But you never, never, never leave I squared in a problem. What is I squared equal to? And so when you multiply that, you would get a -7. You also don't write your answer in that form. When you have a complex number, that's called complex because it has a real number part. That means it doesn't have an I. Part of it doesn't have an I and part of it does have an I. When you have a complex number, you always write the I part, the imaginary part, last. This is the correct form to write that answer. The imaginary part always comes last. What are you going to do to solve the next problem? Before we get to the next problem, if I had a problem like this, how am I going to solve it out? What would I do? What method? I would use a box problem. So how are you going to solve part E? What are you going to do for problem E? So same kind of problem, except it has I's instead of X's. So you're going to multiply it out using a box problem. Once you have the box filled in, then you combine like terms. I have an 8. Those two terms are like terms. Am I finished? No, you never ever leave an I squared in the problem. You always change the I squared to a -1. Now what's that going to do with the 36? It's going to change it to a -36. Now am I done? No, I still have some like terms now. So I combine those like terms. I'm going to write the answer right here at the top. -28 plus 36i. When you have a complex number, part of it's real and part of it's imaginary, you put the I part last. Do I need a box problem for the next example? Example F. Do you see any addition signs in there anywhere or subtraction signs? This is multiplication. I multiply these two together first and get an answer. In place of the I squared becomes -1. That's going to cancel out the negatives. -12 times -1 is going to give me +12. 12 times 2 is 24i. That's your final answer. Am I going to need a box problem for part G? Example number G. Please set up your box problem and multiply problem G. I see some of you using FOIL. That's okay too. Either multiply it with a box problem or FOIL. The 10s cancel out, so I have 4 minus 25i squared. What is I squared equal to? Negative times a negative makes a positive 25, and so the final answer is 29. On the next problem, you cannot just square the first term and square the last term. There's a middle term in there. This is what it means to square a binomial. It means I'm going to have -7 and a +3 on top of my box and a -7, +3 on the side of my box. So you're going to write the box problem down and multiply it out. On example number H, are my 21s going to cancel out this time? Not this time because they're both negative, so I'm going to have a 49 minus a 42i plus 9i squared. But what am I going to put in place of I squared? So that's going to make the 9 negative. 49 minus 42i minus another 9. So this is going to be my final answer. And remember that the I comes last. If it has a real part and an imaginary part, the imaginary part comes last. Now there's two more examples I want you to write on your paper, because these two examples get mixed up a lot. So would you write these down on your paper? I want to talk about the difference between these two problems, because people get these two problems mixed up. So what's the difference? This has an adding sign in the middle between the binomials. If there's an adding sign in the middle between the binomials, is this a box problem? If it's not a box problem, what do you do? And that's called combine like terms. The parentheses are just to group the two complex numbers. In here, in between those two parentheses, is there an adding sign? Do I use a box problem on the second one? Or, what's the other way to do it? If I don't like, does it matter whether you use a box problem or FOIL? No, you get the same answer. But people a lot of times try to do, as a matter of fact, I even saw it on the test yesterday. Some people were trying to do a box problem on this. If there's an adding sign in the middle, it is not a box problem. If there's not anything in between there, that means I'm multiplying the two binomials. And the best way to do that is with a box problem.